Hello, I'm going to do a quick tutorial on quick loads as it applies to our 45 caliber smokeless muzzle loaders. To get started, first thing I select, I'm using version 3.9, I believe that's still the latest version. The first thing I select is a cartridge. So you go up, click that icon, make sure you enter .458 for the 45, say OK. Make sure calibers is selected, say OK. You don't need to start a new file. What that does is that populates the cartridges, every cartridge in that caliber. I like to use 458 Win Mag. This icon brings up a drawing of the 458 Win Mag. Now this cross section would be similar to what we would see inside our barrel, except we're going to have a breech plug down here in a module instead of a case. So the bullet length, overall length of this is going to be slightly different because of our breech plug. Next thing you do is select the bullet icon there. This will open up here, and you're going to want .458 again. You're going to say OK. You're going to want to make sure bullets is selected, say OK. You're going to say no, you don't need to open a new file. That's going to populate the bullet file. You're going to notice there's all kinds of bullets in there, and what you're going to notice is more than likely there's no Pittman bullets, there's no Arrowhead XLDs, there's no Fury bullets, there's no Parker bullets. We don't shoot enough of them for them to make the cut here in this. So I like to do, if I'm going to shoot a 300 grain bullet, like an XLD, I'm going to select a 300 grain Barnes, and then what I'm going to do is I'm going to go to the internet and I'm going to find out how long it is, because I know it's not 1.085, the bullet length here. So you go to the internet, and this is the Pittman site, Arrowhead site. So Luke's bullet is a 300 grain is 1.450. If you're using the AccuMax, you could use this one. But for excuse me, for this one, we'll use the Luke's bullet, and we'll say 1.450. All right. My hunting rifle has a barrel of 28 inches, and that is from the muzzle all the way inside the action, all the threads, the entire length of the barrel. It's very important that you do that, get that correct. It's not the bullet travel, that's this number, okay, and that number is derived by the overall cartridge length, okay. So make sure you get your barrel length correct. The next thing is the bullet weight is correct. Now we're going to look at the case capacity is 95. If you're shooting a charge that's in excess of that, then you need to manipulate this number and the case length number to reflect that, but we'll get into that a little bit later. The charge that I'm going to simulate right now is a hunting load that I use, a 300 grain bullet, H3 80 grains of H322. So I got 80 grains selected in here. I've got H322 selected. It's showing a compressed charge. That's not going to work. We're not compressing it, so I got to adjust the seating depth to get this at 100%. And 100% indicates that the bullet is seated directly on top of the powder charge, which is what we see in our smokeless muzzleloaders. So if I change that to 1.35 inches, that puts that at 100%. Okay, and that's exactly what we want. So the last thing I'm going to do is I'm going to friction proof it, because it's not a cartridge. We're not trying to jump the bullet into the lands and push it. So it's actually a lot smoother because our bullets are already loaded inside the bore of the rifle. So I like to use 0.4. So what this really does, if you say OK here, is it changes the start pressure. And what that does is it's really our loading pressure. The lower this number is, the easier it is to load. The higher this number is, the harder it is to load. So now we're going to say apply and calculate. And we're going to see that which shows here in the results that I've got a chamber pressure of 45,694 psi. I have a feet per second of 2,793. I have a barrel time of 1.248 milliseconds, and the amount of propellant burnt is 98.71%. So to start with the pressure, with the modules, any of the modules will work. The his modules, Luke's modules, the Brown's modules, any of them will work, because we're in a pressure that's more than enough, more than capable of holding that. The feet per second, I think I'm in my hunting rifle, I'm looking at about 2810, I believe, is what my dope chart is set up for. So I'm off by about 17 feet per second, which isn't too terrible. The one thing that I want to notice that I want to change is if I want to get to fine tune this a little bit more, I can change my weighting factor. And what the weighting factor is it's a number that you can manipulate, and it's about how fast the powder is burning. A faster burning powder is going to have a higher number, and a slower burning powder is going to have a lower number. So if once ignition takes place, if every grain of powder burned instantaneously, this would be a 1. If it burns really super slowly and the pressure builds the entire time the bullet is going out the bore, that number is going to be like a 0.01. Okay, but right default for the 458 Win Mag is 0.5, and that got us very close. Okay, so I'm going to change that to 0.45. Hit a pellet calculate again, and it got us even better. The pressure changed slightly, and the feet per second changed a little bit more. Now I'm only off by about 9 feet per second. The amount of propellant burned also changed a little bit. Okay, so this is very close to what my actual conditions. Because the feet per second are very close, I can make the assumption that I'm also very close on PSI, which means it's a very safe load to shoot with my brass modules. Now, one thing you have to understand is that I'm considering that a light load, like a one-handed load. If you want to simulate what this would be with a heavier load, like a hard two-hand load, you could simply turn off the friction proof. Turn that off, say apply calculate, and it jumps up. Now we're at 49.891, and the feet per second jumped up too also. And that's what's actually going to happen in your rifle. If you have a much harder load, the speed's going to go up and the pressure is going to build with it. So obviously we want a good standard deviation on our feet per second here, and we want to keep that number very same from shot to shot. So it's important that we pick a powder and stuff that burns cleanly, so that from load to load, every time you load, it doesn't get harder and harder to load. You want to keep that same, and you want to keep that very, very consistent, so that way this number, the start pressure, is not jumping all over the place. That's a good way to ruin a good hunt. So let's look at a different one. Another one that a lot of people shoot is 4198. If you go to 4198, I haven't shot 4198 in some time, but if we shoot 70 grains of 4198 out of my same 28-inch barrel, we're gonna friction proof it. I'm gonna say 0.4 because I'm gonna say a light loading pressure. I'm gonna change this back to the default of 0.5, and now we're at 94%. So I'm gonna change that. 0.248, so that way we're back the bullet sitting directly on top of the powder charge. Say apply calculate, and that's 50,000 psi, 2753 feet per second, and 100% a complete burn. You can see from the pressure trace here that's what that's showing you, and this is a very interesting box here that you can look. This is the velocity trace, and this is the pressure trace. Now, in your application, if you look at your lab radar or your magnetospeed, whatever it is you're shooting, if you look at this and you have a different, a little bit faster, you can also change this again, 0.45 or even 0.4 if you think that if it's not, and you'll see that your numbers change as well. But this is pretty close to what I remember getting. That speed is pretty close to what I was getting in 4198, when I shot it a while ago. The other thing is, so if you want to get into the barrel time, you can look up online what your optimum barrel time is, and you can use this number to kind of tweak it and tweak the charge to get to where your barrel time needs to be to find out. One thing you have to understand is you got a brake on there, and that affects the barrel time a little bit. But I'll usually use this number to start my Saturday test. If I know that this is close, if I go online and if I just search for this one I like. So for a 28-inch barrel, and this node is 0.27, 1.27, or 1.28 for the fourth node, and we're at 1.22. So it's we're in between node 3 and 4 on there. So you would use this data then to start your Saturday test. I'd say start at at 68 and go up in half grain increments up till about, and then once you find your optimal charge weight, then you can dial it in from there and get you a good load that shoots 500 yards, and with a good ES and a good even cleaning, and there you are. If you guys have any questions or you want some traces done or what have you, give me a holler. Thanks.